Alright guys, I'm a little late on the video, but I want to go ahead and get this out for you guys. I don't know if I'm going to be there tomorrow, so you're either watching this on your phone at home or you're watching it in class. So here we go. We're going over solving quadratics by graphing and factoring. I kind of went over this a little bit today in class, but let's just touch on this. Let's go pretty quick since you can pause, rewind, etc. All right, so remember, when you're looking for roots, solutions, x-intercepts, or zeros, all that means is where the quadratic function crosses through the x-axis. Okay, and so also remember, when we're dealing with quadratics, you're looking at U-shapes like such, either open upwards like that or open downward. Okay. Let's erase that. So all we're looking for is where it cuts through the x-axis. Hopefully you know where the x-axis is, but if you don't, there's your x and here is your y. On this particular function, it is cutting through right there and right there. And the first one is a -1, so x is equal to -1. The other one is at 3. So there's 1 and there's 3. So x is equal to 3. And those are your solutions for that quadratic. Let's go on to example 2. Again, your x-axis is there, your y-axis is there. We're looking for where the quadratic crosses the x-axis. Remember, this is the x-axis. Right here, you see it's going through -3 and 4. Let's mark that. Let's go blue this time. And you have two solutions. X is equal to -3. X is equal to 4. And moving along, next section of your notes here. It says, let's start by graphing a quadratic to the x-intercepts. Graph the function, and you see the function listed here. Y is equal to x squared plus 2x minus 3. And I'm going to write up here standard form, which is ax squared plus bx plus c. That is what a quadratic looks like in standard form. Okay. What we're going to do in order to graph this is we're going to use our table in our calculator. Okay. And so I'm going to go over to some images here, and then I'll come back to this page. All right, so the first thing we want to do is we want to go to the table key, which is right here on your calculator. Once we go, so I'll circle that, table key. Once we get in there, you're going to go then, and you're going to go down to edit function. So again, I'll circle that. And then when you get in there, you'll see the function f of x, which is the same thing as y. Type in your function right there. Your letter, you can't see it on this image, but if you go over here, that's where you put in your x right there. So just press that key one time. And then to put in the square, once again, go back here. That'll give you your squared. And then just type the rest out. Once you do that, just make sure you're starting at 0 and step up by 1, and then you go down and hit calculate, and then you'll come to a table like this. Okay. In the calculator, wherever x is 0, that means that's the y-intercept. So in this particular function, the y-intercept is -3. Vice versa, wherever y is 0, that's where your x-intercept is going to be. Okay, so let's go back. And so we're back at the table here. All we're doing is we're going through our table on our calculator, and you want to go to where the x side is at -3, and then you write in your values from the y side. So you got 0 at -2, y is -3. At -1, it is -4. At 0, it is -3. And at 1, it's 0. And so now we've listed out all of our outputs. And so if you look at this right here, each one of these columns is your ordered pair. And so we could also write that as, so I'm right down here to the side, -3, 0. And that's the point on the graph. So if you follow it over here, we go to our x-axis. Let me label that for you. You go to our x-axis, and then you go to -3 on the x-axis, and then y is 0. And so we're not going up or we're not going down. So we're staying right there on the line. And that is our y-intercept. So -3, 0. And the next one is -2, -3. -1, -4. 0, -3. And 1, 0. And we're expecting it to be a U-shape. You see we've got a U-shape going here. There you are. I apologize, I sound monotone. Clearly I'm sick here, but I'm trying to make sure you guys have this video. So here it's asking for our x-intercepts. We know where to find those. Go to the x-axis. There is one there at -3. Fill that in. And then there is another one here at 1. So we'll put that in. Okay, let's move along. So now let's solve by factoring. We already know how to factor. Let me go ahead and write the ax squared plus bx plus c. Remember, this is standard form. And so let's look at example number 1, or number 4 here. I don't know why that says example 4. I guess the other ones are 1 through 3. So you see here we have this is set equal to 0. Okay, it's very important to note that, because if it's not set equal to 0, that means you have to get one side set equal to 0 before you can solve it. Also take note that there's 2 terms here. Okay, there are 2 terms here. And I told you prior to look for a difference of 2 squares when you encounter only 2 terms. And so it appears that this is probably going to be a difference of 2 squares. Also, first thing we want to look for all the time is the greatest common factor. And so we got to ask ourselves, does 6 go into 54? And the answer to that question is yes. And so we know our GCF in this case is 6 because they don't have a variable in common. And so the only thing we can take in this case is a 6. And so we'll write our GCF here to the side, 6. And then we put it out front, and then parentheses. Told you guys that if you started like this, when you pulled out a GCF, that means inside your, so you started with 2 terms, so inside your parentheses there's going to be 2 terms. So it'll be something minus something. And so we'll put that here. And how do we figure out what that something is? Well, we divide by the GCF. Excuse me. And so let's start with our numbers first. We have a 6 divided by 6. That is a 1. And then you have a variable not over another variable. So you just bring that down. X squared. We don't really need the 1 there, but we'll leave it there. Right, and then you have 54 divided, or negative 54 divided by 6, and that is equal to 9. And so some of you guys like to stop here. We cannot stop there because we pulled out the GCF, and then inside we have the difference of two squares. So when we have the difference of two squares, we want to go ahead and take the square root, and that leaves us with x minus 3. The square root of x squared is x, and the square root of 9 is 3. Don't forget to bring that your GCF. And remember, when it's a difference of two squares, one's going to be negative, one's going to be positive. And so you'll have x plus 3. And then one last step is you want to set both of these inside the parentheses equal to 0. And then that's how you solve it. So you got x minus 3 is equal to 0. And then you have x plus 3 is equal to 0. I know you guys haven't quite gotten into solving yet, but this one should be pretty easy. So we have, let's undo that. We have x minus 3 is equal to 0. We want to get x by itself, so that means we have to get that negative 3 off of there. The opposite of a negative is a positive, or the opposite of subtraction sign is an addition sign. And so we got 2, add 3 on that side, and let's look at that as two different sides. If we have 3 on the left side, that means we have to add 3 on that side. That means that cancels, leaving the x by itself equal to a positive 3. So one of our x-intercepts is x is equal to 3. Let's look at the other one. So we have positive 3 here. So it means we have to do the opposite of that, which is let's change ink color here, which is subtract 3. Whatever you do on one side has to be done on the other. That cancels. It leaves x by itself is equal to negative 3. So I'll move it up here. X is equal to 3. X is equal to negative 3. So it seems like a lot of steps, but really all we've added in addition to what we've already learned is setting both of your factors that are inside the parentheses equal to 0 and then solving it. Okay. All right, let's move on to example number 5. Okay, so this one, I told you initially that we want it set equal to 0. Well, this is not set equal to 0, and so we have to get this 12 off of this side and over to this side. So let's go ahead and do that. This is a positive 12, so we subtract it. We do it on that side, so we have to do it to this side. That cancels out, becomes equal to 0, and then you have a 2x squared plus 5x minus 12. So now we have our quadratic in standard form. We want to see if we can get a GCF out of this. We can't. They don't have, all three terms don't have a variable in common, and this 5 is a prime number, and so we can just get straight to the factoring. I taught you guys to use the x, Then we'll multiply a negative 12 times a 2. That gives us negative 24. And then bottom of the x, we'll put 5, which is our b term. So the top is negative 12 times 2, goes there. And then the bottom is always just this b term that we got from there. Okay, 5 there. Now on the sides, we're looking for two numbers that multiply to give you negative 24, and then add or subtract to become negative 5. So we want to combine these two numbers. Those numbers are 3 and 8. And so we'll have a negative 3 there. And guys, you always want to check and make sure your numbers are right. This is where you guys make mistakes. Okay. So ask yourself, is negative 3 times 8 equal to negative 24? Yes, it is. Is negative 3 plus 8 equal to 5? Yes, it is. If you don't know, punch this stuff in your calculator and make sure we're getting the right stuff. Excuse me. So, we have our factors. X 3, x plus 8. So now, don't stop here. I noticed on the last test, some of you guys did, but remember we used this 2 to get this negative 24 by multiplying it with negative 12, okay, right here. So we multiplied these two right here. It means we have to get that 2 back out of there. How do we do that? Bottoms up, so we're going to divide by 2 there and divide by 2 there. This does not simplify, and you can check that again by putting in your calculators, because that was another mistake that I noticed. Okay, so that does not simplify, so bottoms up, we'll bring that up there. 2x minus 3. And then this one does simplify. Put it in your calculator. To x, there we go, x plus 4. And then we'll set both of these equal to 0 and solve. So you have, let's work with the left side first. Right here. So you have a negative 3, so we'll do plus 3. Get that on that side, so we got to do it on this side. That leaves us with 2x is equal to 3. And then we have a 2 next to an x. That is multiplication. Opposite of multiplication is division. So let's divide by 2 to get that off of there. And to get x by itself. And we have x is equal to 3 over 2. Okay. Opposite side, we have x plus 4. In order to get that positive 4 off there, we have to subtract 4 on both sides of the equal sign. That cancels that. It leaves x is equal to negative 4. So x is equal to negative 4. So our x-intercepts, solutions, roots, whatever you want to call them, we have one is x is 3 over 2. One is x is equal to negative 4. And then our last example here is example 6. Notice it's not set equal to 0. You got x squared over here, and then the other two terms on this side. Now, one thing to note, we never want the x squared to be negative. And so we want to get these two terms from this side over here to the left side, so we don't have to worry about x squared being negative. So how do we do that? We have a negative 5 there, so we got to add 5. Both sides. That cancels that out, and it leaves x squared. Actually, let's go back, because I don't want to get you guys messed up. Let's start with the 6x, so it's automatically in standard form. So we have a positive 6x, so we want to take away 6x to cancel that out. And that leaves us with, remember to keep it in standard form. Your square term first, then the term with the x on it, then the number. So it is x squared minus 6x. This canceled, so we have is equal to negative 5. We need that negative 5 off of there, so we'll add 5. Add 5. And that leaves us with x squared minus 6x plus 5 is equal to 0. Let's write that out here. X squared minus 6x plus 5. And so now we go into factoring. A times C is at the top, so 5 times 1. We got a 5 there and a negative 6 there. We need two numbers that multiply to give you 5 and add or combine to give you a negative 6. That would be a 5 and a 1. 5 times 1 is 5, but 5 plus 1 is not negative 6. So we change our signs to negative 5 and negative 1. That now works. We have our factors of x minus 5 and x minus 1. Notice, if you look back here, when we have our factors, x minus 3, x plus 3, notice when there's no term out here in front, all you're doing is changing the sign. Okay, and so we had an x minus 3. When we solved for it, it became a positive 3. Here, we had an x plus 3. When we solved for it, it became a negative 3. So go back to this example. We have an x minus 5. When we set that equal to 0 and solve for it, it's just going to become a positive 5 as long as there's no term out here. Same thing on this side. If we have an x minus 1, when we set it equal to 0 and solve it, it's going to become a positive 1. So let's go ahead and do that. So we got x minus 5 is equal to 0. Want to get rid of that 5 on that side, so we'll add 5, add 5. That cancels, and it's x is equal to 5. Let's do the other one. X minus 1 is equal to 0. We want to get that negative 1 off of there, so we add a positive 1 on both sides. That cancels. That leaves an x and a 1. So x is equal to 5. X is equal to 1. And those are your solutions. I'd recommend actually practicing these problems right here before you just watch me go through it. I'm going to go through it right now, but pause the video, try to practice it, and then go from there. Then you come back and check your answer. Let's proceed. So we check. We see that this is set equal to 0. Check for GCF. There is no GCF, so we get straight to factoring. Guys, remember you can check these answers in polysolve once again. Let me write our standard form up here. X squared plus bx plus c. Okay, let's factor. Got a 16. You got a 10. We need two numbers that multiply to get 16 and add or subtract or combine or however you want to call it to equal 10. And that is an 8 and a 2. Sound right? 8 times 2 is 16. 8 plus 2 is 10. And so we got x plus 8, x plus 2. Excuse me. And then we want to go ahead and solve for that. So we want x to be equal to something, so we got to set both of those equal to 0. Since it's already set equal to 0, our factors would be equal to 0. And so technically that would be written like this. And so now we can take our x plus 8 is equal to 0. Remember, I told you it's going to end up being just the opposite of this since there's no term out here. So we got positive 8, subtract 8, subtract 8. That cancels. It leaves x is equal to negative 8. And then on the other side, we have x plus 2 is equal to 0. We want to get rid of that 2 and get x by itself. And so we subtract 2, cancels. It leaves x on that side. X is equal to negative 2. And once again, notice sign change. Positive 8 to negative 8. Positive 2 to negative 2. Only when there's no term out here in front of the x. Or I'm sorry, no coefficient. Or a coefficient equal to 1. Moving along to example number 2. Once again, it's already set equal to 0. Okay, so next we look for a GCF, and there is no GCF. That is a prime number, and so is that. So we get to go ahead and factor. And so up in top of our x, it's a 6 times negative 3. Gives us negative 18. And then our b term goes at the bottom. Two numbers that multiplies to give you negative 18 and comes together by adding or subtraction to give you 7. That would be a 2 and a 9. We need it to be 7, so right there. Negative 2 times 9 is negative 18. Negative 2 plus 9 is 7. So we have our factors of x minus 2, x plus 9. Remember, in order to get this 18, we multiply by 6, so we got to get the 6 back out of there. Let's divide it back out. Divided by 6. Divided by 6. Remember, bottoms up. Before we do that, we have to simplify. Put it in your calculator. Just punch it in as a fraction and see what happens. Some of y'all messed that up on the test. That simplifies to once it's simplified, you do your bottoms up, swing the 3 up, and that equals 3x minus 1. Your 9 over 6, that simplifies to 3 over 2, so that's x 3 over 2 simplified. It's already simplified now, so bottoms up. That leaves you 2x plus 3. And they're both equal to 0. And so let's set it up and solve. 3x minus 1 is equal to 0. Let's start by getting rid of the number. That's a negative 1, so a positive 1 to get rid of it, plus 1. That cancels. Leaves a 1 on this side and a 3x on that side. 3x, same thing as 3 times x, so opposite is divide by 3, and then you get x is equal to 1/3. Notice, when we're doing our bottoms up, I don't think I've pointed this out yet, is once you simplify our fraction, before we do the bottoms up, it's already in this fraction form, and so there is no term out here yet. And so you could technically do what I was saying before, which is if there's no term out here, you change the sign, and that'll be what x is equal to. So if we were to just change this sign right here to a positive, x is equal to 1/3, and x is equal to 1/3. So the same thing here. it's going to work out. I'm going to do the math for you, but I'm going to show you it works out here. So you got x plus 3 over 2 before we swing the 2 up. Well, change the sign, it's going to become a negative 3 over 2. And so let's do the math out here. So you got 2x plus 3. Oh, I'm going into my other space. Let's do it somewhere else. 2x plus, dang, it's tripping, plus 3 equal to 0. We want to minus 3. That cancels. That leaves a 2x is equal to negative 3. Opposite of multiplication is division. That 2 cancels. It leaves an x. Got to also divide on that side. X is equal to negative 3 over 2. Again, before we swung this up, we had a positive 3 over 2, changed the sign, and it would have been a negative 3 over 2. I will be in class. If I'm not in class with you now and you're watching this, I should be there by tomorrow. So, and then our last example here. Sorry guys, I'm just feeling bad, so bear with me. Example number 3. Once again, it's already set equal to 0. We have 2 terms here, and so this isn't a negative though, so it's not going to be a difference of 2 squares. So hang on. So let's work this out. We got, separate a little bit here. First thing, when factoring, we're looking for a GCF. Ask yourself, does the smaller number go into the bigger number? Does 5 go into 10? Yes, it does. That means 5 is going to be part of the GCF. Then look, is there a letter in common? Yes, there is. If there is a letter in common, you take the one with the smallest exponent. In this case, it is just an x. So 5x is the GCF. Okay. So now you got, excuse me, you have 2 terms here. Oops. 2 terms here, which means you're going to have 2 terms in here. How do you figure out what those terms are? Divide by the GCF. 5 divided by 5 is 1. When dividing exponents, remember this one has an invisible 1 there, so that's 2 minus 1, which leaves 1 as the exponent. And then 10 divided by 5 is 2. And then exponents are going to cancel out because you have a 1 subtract a 1, which leaves 0. And this is all set equal to 0. So this is a little bit different than the prior 2 because we were setting our parentheses equal to 0 and solving for x. Well, now we have a GCF out there as well as a set of parentheses, but there's an x out here, so we can still set that equal to 0, can't we? And so we have 5x is equal to 0. And so we have 5 next to x, that's multiplication, so we can divide. That cancels there. We have x is equal to, that's 0 divided by 5, that's going to be equal to 0. If you don't know that, put it in your calculator, and it'll tell you. And then you got the next one, we got an x plus 2 is equal to 0. We know that's going to end up being a negative 2 because it's going to be the opposite sign. But let's see, how do we get that 2 off of there? Minus 2, that cancels. X is equal to negative 2. If I went too fast for you, you can always go back and play this over and over again to kind of just get a refresher on it. And let's go ahead and go to the last example. A lot of times when you guys see words, you lose your minds and act like you don't know how to do it. Well, what exactly are we doing here? We're just solving, correct? And so just apply the same principle to the application problem. If you're reading it, well, what have we been doing the whole time? Factoring and solving. So, well, let's factor and solve then. So it says a ball is thrown up with an initial velocity of 32 feet per second at a height of 240 feet. Use the equation here. H of t is equal to what you see there. Notice it's saying velocity right there and height right there. Okay. So it's giving us the velocity and it's giving us the height to plug in. So let's go ahead and do that. We got negative 16 t squared, and then velocity is 32, and so we'll add that plus 32 t, because your t is there. So we plug in velocity for this right here, v sub o, and then the t's in place. And then height is 240 feet. So the one part that you actually have to really think about is it wants us to find when the ball hits the ground. Okay, and so the height is going to be 0 when the ball hits the ground, right? That's the one thing you got to kind of just figure out. Okay, so it says a ball is thrown up. Initial velocity is 32 feet per second at a height of 240 feet. You're using the equation there to find the ball when it hits the ground, or find out when the ball hits the ground, and that height is at 0. And so now we solve. Okay, so first we're looking for, as always, the GCF. We're going to ask if a 16 can go, the smaller number can go into the larger number. In this case, we have 16 and 240. Also, remember I told you guys, if the first term is negative, when we factor out our GCF, that is also going to be negative. Okay? So we have 16. It does go into 240, and it also does go into 32. And so we found our GCF of 16. But again, remember it's going to be negative. So we have negative 16. Now we have parentheses, and we have 3 terms before we pull out the negative 16. So that means we're going to have 3 terms on the inside. So how do we figure out those 3 terms? Divide by negative 16. Negative 16 divided by negative 16 is 1. Then you bring your t squared down since we're not dividing by the variable. Divide this by negative 16. And that becomes a negative 2, because you have 32 divided by negative 16, so it changes the sign. You bring down your t. And then 240 divided by 16 becomes, negative 16, I'm sorry, becomes a negative 15. And so now we start our factoring. Remember, we can't just stop here. We have to factor. So we got our x. We have a negative 15 up there and a negative 2. We need 2 numbers that multiply to give you 15. Add to give you a negative 2. That's a 5 and a 3. We need the 2 to be negative, so we'll make that there. Check and make sure it works. I know it does. X plus 3. Remember, negative 16 is out there. All right, and so now we set equal to, well, I guess it doesn't matter, but I put X here. It's a T. So let's keep it consistent. T minus 5, T plus 3 equals to 0. So now we solve. We have a T minus 5. We should know by this point or this time that that's going to end up being a positive 5, because we're going to add 5 to get rid of it from that side, add 5 to that side. That is T is equal to 5. And then the other one, that's T plus 3. We should know that this is going to end up being a negative 3, because we're going to minus 3 there, minus 3 there. That leaves T is equal to negative 3. And so now we got to figure out what this means. We have T is equal to 5 and T is equal to negative 3. Well, we know we're dealing in time, and it wants to know what time the ball hits the ground at 0, right? And so can we have negative time? No, we cannot. And so we know it can't be negative 3, and so it must be 5 seconds. When the ball hits the ground. Okay, hopefully this helps. Watch it, work, and hopefully I won't be sick and come back and be able to kind of just further drive this home for you guys. All right, have a good one.